Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 1.7 entitled Tables and Graphs. And our objectives for today are going to be to use a table to construct a bar or line graph and to interpret the meaning of the data shown in the bar or the line graph. And in math, we use tables and charts and graphs to organize data and to gather information. And you really analyze tables and graphs a lot in science. You use it in statistics. So at the end of this school year, we'll have a unit on statistics, and there will be a lot more analysis with charts and graphs. So for now, some of this might be a little bit of a review. We'll be making the bar graphs and the line graphs, and we'll be analyzing the data that is in the tables. So this should be some easy calculations and some observations and construction. That should be review for you. So in our first example here, they're giving us a table. This data table shows the number of students in millions who are enrolled in school in the United States. Okay, and it goes from 1980 all the way up to the year 2000. And it breaks the students down by age groups. We have 3 age categories. And after this table, there are 3 questions about it. It says which year had the least number of student enrollment, and then which year had the greatest number of student enrollment, and then did the total enrollment increase for each 5-year period. So before we can begin to answer these questions, we have to do a little more work with this table. Since these questions are asking about the totals for each of these 5-year periods, we're going to have to go through and we're going to have to do a little work where we find out what those totals are. So we're going to add down these columns. We're going to add up all these numbers for each column. So in this first column here, I'm going to have a total of 18,199. If I add down the second column, I'm going to have a total of 17,732. My third column going down would have a total of 16,697. My fourth column is going to have 18,922. And then my final column is going to have 20,500. Now remember, those numbers are really in millions, okay? But we don't have to be too nitpicky. The original problem told us it was in millions, but again, we're just trying to figure out for now which one had the least and which one had the greatest. Okay, so which year had the least number of students? Well, now that we have these totals, we just have to look at the totals and figure out which one is the smallest. And that would be right here, 16,697. So in year 1990, the enrollment was the smallest. Which year had the greatest number of student enrollment? Again, you're going to look at all of these totals, these 5 totals that we found. The biggest is going to be the 20,500 in the year 2000. And did the total enrollment increase for each 5-year period? So again, we're going to look back at these totals. And even from 1980 to 1985, that didn't increase, that decreased. And 1985 to 1990, that was a decrease again. The last 5-year chunks, those increased, but there wasn't an increase for every 5-year period. So my answer to that third question is going to be no. So you're going to see problems like that in your homework where they're going to give you a table or a chart and they just want you to interpret some information and answer questions about it. Okay, now for example 2, we're going to refresh our memories on how to draw a bar graph. Here we have a data table, and it represents the number of worldwide shipments of personal computers in millions. So this was in the 90s. This is how many people were buying PCs. Okay, we're not going to get into a conversation about PCs versus Macs or anything like that. We're not going to overinterpret the data. We're just going to take it for what it is. Now this table looks a little funky. It's a horizontal table, and we're supposed to make a bar graph from it. So when we're making our bar graph, we want to remember that the first row going across the table is always going to represent the x-axis. And the next row is going to represent the y-axis. So when I'm drawing my bar graph, I might need to scooch down a little bit so I have a little bit of room. We're going to draw our axes. And we only need to draw the first quadrant because we're assuming that all of our values are going to be positive. So on my x-axis, the first value I had in my table, the x-axis is representing the years. So I can put years across the bottom. And it started in 1990, so I can have a little mark for 1990, 1992, 1994, 96, and 98. Then my y-axis, my vertical axis, is going to be the PCs. And the number of PCs that were shipped was in millions. So we want to make sure that we put in millions. So that way anybody looking at this chart knows how many our numbers on our axis are representing. How many of what? So my first value now in my chart starts at 23.7 and I go all the way up to 98. So I get to control my units here and my increments. A good way to count from 20s to hundreds might be by tens. So I could start at 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So we want to kind of evenly space our amounts here. So let's say I started at 10, let's put 20, 30, 40, 50, 60, 70, 80. So I won't label every single one just because it would be a little cramped there on the side. And now to make our bars, I just have to read that in 1990, there were 23.7 million. So in the 1990 range then, or spot, I'm going to go up to about 23.7. I'm just going to kind of estimate as best as I can as to where that would be. I'm going to make a little bar. If this mark here is 20, I want to be just over it just a little bit. And you can color it in if you want. If you want to use colored pencils, markers, highlighters, whatever, you can be creative and colorful when you're making your bar chart. In 1992, there were 32.4 million. So I'm going to make a bar that goes up to about 30 and then a little bit past, and then back down. Again, I can color that in. In 1994, there were 47.9, so I'm going to go up to 40 and almost up to 50. Now, if you want to use graph paper for this, your graphs will obviously be a lot nicer and neater. But since I'm doing this freehand, it might be a little bit of estimation that's going on here. Now, 1996, there were 70.8. So if that mark is 70, I just want to be slightly above it or close to it. And then in 1998, there were 98.4. So I'm going to go almost all the way up to 100. There we go. So we have all our bars drawn. Now, we have our bars drawn. We have our axes labeled. There's one more thing that we need on this graph, and that is a title. And this was dealing with worldwide shipments. Whoops. H. Of PCs. So just make sure you put a title that describes what this information is in your graph. And that's usually something that students overlook is the title. Now when you take your quizzes and your test, we'll give you a point for each of the axes being labeled and then your title across the top. So making sure that you have all those details complete can save you from losing points on a quiz or a test. Okay, in example 3 now, we're going to make a line graph instead of a bar graph. And again, we have a horizontal table where her data is presented. This is a table that represents the number of people over the age of 65 in the United States. And again, these are the number of millions of people. So again, remember this top row represents the x-axis, the bottom row represents the y-axis. So I'm going to scooch down here again, and I'm going to draw my x-axis and my y-axis. I only have to draw the first quadrant. My x values was the year again. And we're starting in 1960. We're going every 10 years. So 60, 70, 80, 90, and then 2000. I can just put 00 for that. And then my y-axis is the number of people. And again, this is in millions. So number of people in millions. Whoops, sorry about that. Whoops, come on now. There we go. Okay. Now again, I want to look and see what my increments are. I'm going from about 17 up to about 40. So again, a good increment for this axis might be by tens. 10, 20, 30, 40. And you could space it out more if you would like. You could count by fives if you would like. Just make sure that you're able to represent the data clearly. And then to make a line graph instead of a bar graph, I'm going to plot points where each of the pieces of information is. So in 1960, there were 17.4 million people. So instead of drawing a bar, I'm going to go up to about, at 1960, I'm going to go up to about 17.4 and put a little dot. In 1970, they were 21.4, so I'm going to go just a little bit past 20 and put a dot. In 1980, there were 27.8, so I'm going to go almost up to 30, but not quite. In 1990, there were 34.3, so almost halfway between 30 and 40. And then in the year 2000, there were 39, so almost all the way up to 40. So I have a point for each of those pieces of information, and then I'm going to connect my points with little line segments. Now, a common mistake that students make is they connect the origin with the very first data point, and we don't want to do that because that says that the data point 00 is in your table, and that's not true. In this case, our table started in the year 1960. So this is our first data point. So that's where we want to start connecting our lines. Okay, so I labeled my x-axis, I labeled my y-axis, I drew my line graph. Now I need to put a title on this. So this could be we could say 65 plus in the US. Okay, that's kind of an abbreviation, but hopefully you get the idea that we need some sort of title. We could say the number of people over 65 in the United States. Okay, just make sure you put some kind of title to describe what that information is. Okay, now for example 4 and example 5, they gave us the table, or I guess in this one it's a bar graph, and we're going to answer questions about it. So we're kind of reversing the process now. So now we're analyzing a bar graph that they've already constructed. Now this bar graph shows the type of transportation that students use to go to school at Adams High School. And when I made this in Excel, the label for the y-axis got cut off. So this over here should actually say that this is the number of students. And it's going to be in hundreds. And I'm sure you could interpret that, but just to clarify, that is technically missing. Okay. And we would probably need a title too on this graph. The title got cut off. So this is the different types of transportation. Okay. But they label each little part of the x-axis across. We've got the 10th, 11th, and 12th graders. We've got a different color for each year of high school, or I'm sorry, not each year, each type of transportation. They're taking the bus is blue. If they drive their own car, that's red. And if they walk, that's green. So looking at this graph, we can hopefully answer these questions. We have A, B, and C. A says, which class has the most students riding the bus to school? So the bus is the blue. So we want to look at the bars that are blue and figure out which one is the most, which one is the tallest. And it looks like right here, 10th grade. This one is clearly the tallest. It's taller than the rest. And it doesn't say how many. It looks like it might be 225 maybe, since it's between 200 and 250. Looks like it's kind of in the middle. Okay. But we aren't asked that at this moment to interpret how much it actually is. We need to know which one is the most. So that's going to be our 10th graders, our sophomores. Okay, question B says, which two classes have the same number of students walking to school? So the green is the code for walking. So we're going to look at these green bars. And the two that are the same are the 10th grade and the 11th grade. So that means there's the same amount of sophomores and juniors that are walking to school. And then you can see question C there says, what is the most common form of transportation amongst 12th graders? So if we go back up to our bar graph, the most common form of transportation for the 12th graders is still the bus. Okay, we can see that there are a lot more people from sophomore, junior to senior year who are driving. There are fewer people who are walking, but still that bus is the most popular form of transportation. And again, we don't know why. We're not asked to interpret that data. Maybe this is a school district that is really spread out, so it's hard for people to drive to school. We don't know. But that is the type of analysis that you could do in these sort of situations. Okay, one last one. We're going to look at a line graph and answer some questions about it. And this is a line graph that shows a company's revenue and expenses. So let's put that title up here. Revenue and expenses. And it's in thousands of dollars. So over here, that would be our dollars, our dollar amount, and it's in thousands. Okay. And this shows the company's revenue expenses for 6 months. So it's starting in July and going through December. So it's the last half of the calendar year. The green line is the revenue. I'm sorry, the blue line is the revenue. The red line is the expenses. There is no green. When I did that in Excel, you had an option for 3, and you can't make that third key go away. And again, we have 3 questions that we're going to answer about this. So it says, in what month was the revenue the greatest? Now, revenue is the amount of money that the company takes in. That's the blue line. So we want to look at the blue line and see where it's the greatest. So we want to find the highest point, and it looks like right there in December. And again, we're not asked to interpret how much revenue they made, but it was just over $60,000. And part B says, in what month were the expenses the smallest? Okay, so December we're being asked about the expenses, and we want them to be the smallest. So we're looking at the red line, And we want to see where it is the smallest. And it looks like it might be a tie between July and November. And they're not super duper clear on their actual values, and we would be estimating a little bit. I could maybe draw in kind of a line here and compare where they would go. It's kind of hard to draw a straight line. So I think you could make a case for saying that there might be more than one correct answer here. Um, their expenses might have been the smallest in either July or November. And then part C gives us a little bit of a definition here. It says that the profit is the difference of revenue and expenses. So remember, difference is one of our vocabulary words that means to subtract. So if you took the revenue and subtracted the expenses, then you would get your profit. And that should make sense. Revenue is the amount of money that you have coming in. And if you subtract off your expenses, everything that you spend, your leftover amount is going to be your profit. Okay? So it says, what is the company's profit in July? So we're going to go up to the graph now, and we're going to interpret some data from this graph. I'm going to get rid of that blue dashed line just so it doesn't confuse us. Okay. So in July, we need to kind of interpret or read from the line graph where the expenses and where the revenue were. And it kind of looks like the revenue might have been about 48,000, and so let's put a little 48 by that. And the expenses might have been, oh, I don't know, maybe 38, maybe 39. Seems like that's pretty close to the 40 line there. So let's just say that those are our values. Okay, so there was 48,000 for the revenue and 39,000 for the expenses. So that's going to give a profit of $9,000 if you subtract those two. And that was for July. And again, this question does have a second part to it, so we're going to have two answers. It's a two-part question. It says, what was the company's profit in September? So we're going to do the same thing. We're going to go up to the graph, and we're going to see if we can figure out, here's September. So it looks like there is a point for the company's revenue. That might be about 39 again, maybe 38. And up here for expenses, uh-oh, their expenses are above their revenue. So right about there, that might be 55, maybe. Okay, so let's just say that this value again is 39. Let's just say that that value is 55. Again, it could be open for a little bit of interpretation. Okay, so in September, we would have 39,000 for the company's revenue, and then we have to subtract the 55,000 for their expenses. So that's going to give us a negative value. It's going to be negative $16,000. So that's not actually a profit, that's a loss in September. So September wasn't a good month for this company because they lost $16,000. So again, we don't know what this company is. We aren't asked any questions, to make up a story or imagine a story about it, but this is, touching at some real world applications here for data analysis, because this is what a company would do. They would want to analyze their profits and their losses and maybe ask what was going on in September. Why did they lose that much money? And if they lost that much, did they make it up later in other months? Okay. So you'll have some homework tonight out of your book, and I have a feeling that this homework set might not be the actual correct homework set. So let me edit this. I think there was a typo there. It should be numbers 6 through 25 and 26 through 42 even. Okay, so that should be the problems that you do for this homework set. And remember, you also have your exit problems to do. If you have any questions, you can come see me before school. Good luck and do well.